We will keep on moving. So next up, we're going to take a deep dive into grammar and syntax of GraphQL with Mohith Shrivastava. Mohit, how's it going today?
Hey, it's going good. Thanks for having me on this conference.
Awesome. Glad to see you, and just take the stage and it's all yours.
Thank you so much again. Hey, everyone. Welcome to this talk on deep dive into GraphQL grammar and syntax. My name is Mohit. I'm a lead developer advocate at Salesforce. This is my Twitter handle and an email here in case you want to reach out to me. And also, I work for Salesforce. So, Salesforce is one of the leading enterprise software companies. We provide software and also give platform so that you can connect your business with customers. So we have a software to unify different things, unify sales, marketing, and provide a 360-degree view of the customer. So I work for Salesforce, and today I'm really excited for this deep dive into GraphQL grammar and syntax. And this talk I specifically designed for folks who are very new to GraphQL, like me. I learned GraphQL 6 months back, and I thought I'll share some of my experiences learning it and sort of synthesize the GraphQL spec and the grammar for you in 20 minutes here. All right, I'm going to move on to the next slide. So before I begin, right, what is GraphQL all about? Like, what is GraphQL? For this agenda, we'll talk about GraphQL, why GraphQL, how GraphQL works. So these are all the questions that comes up when you look for what is GraphQL, and then specification and the implementation considerations. So GraphQL is a query language for your APIs. That means, today when you take any databases, you have query languages, but APIs does not have query language in general. With REST, you really miss that capability of asking the with REST, the client, like your browser or your client that is calling that server, never had the power to ask what is exactly needed. Now you'll read this sentence very often when you are browsing for what is GraphQL. So the real advantage of the GraphQL is the power, to power that the client gets to ask server what is exactly needed. That means, if I need only 2 fields for my application, I have that capability. And we'll deep dive into the syntax and how GraphQL does all of this as we proceed along. All right, next step, why GraphQL, right? We have, that we have REST, we have RPC for communicating between server and the client. Why do we need GraphQL, right? So let's consider an application like this that you see, a mobile application here on the left. Now, if I had to build this application, as you can see, this application requires a lot of content, a lot of data, and these data might reside in different schemas, different systems. So when you're building this with, let's say, REST, you need multiple HTTP callouts to fetch that information for you. So that's where your application can get a little bloated, because when you call a REST endpoint, it might return results that your application might not need. I mean, there might be few attributes that you need, but not everything, right? Any application, REST application is not specifically capable of specifying fields to retrieve. It's usually monolith, and as the services get developed, you keep adding more and more fields. So when you are building a cross-platform mobile application like the one that I've shown you on the left, if you were to build with REST, that's the challenge, to design REST so that to provide you the capability so that you can request for what you want. That's something that a lot of developers don't consider, and that's why we have GraphQL. So if we build our services, or backend services, or an APIs with GraphQL, you need just one call, and you specify that GraphQL query, and with the server is intelligent enough to give you those details, give you only those details, avoiding underfetching or overfetching of the data, so your app actually has a better performance, right? So it's not only that, right? You'll see that the GraphQL also has improved developer experiences. Generally, as an API consumer, we don't get that experience, so it's not usually strongly typed. And one of the things with GraphQL that I like personally is it's strongly typed. That means it has an improved developer experience. The next thing that I want to talk about is control over data fetching and performance, right? So again, as I said, with GraphQL, you get that control. where you get that flexibility of not having to overfetch or underfetch the data, and also your apps are generally more performant. So these are some of the benefits of why GraphQL versus REST. All right, now having looked at GraphQL, how about we do some GraphQL and see how GraphQL works, and then I can go into the language and the syntax and talk about it. So the best way as a developer to sort of uh, explore GraphQL is by actually taking a GraphQL API that's public, like the one that I have here. So you can find it on the GraphQL. Um, there is a swap API GraphQL. So SW is basically Star Wars API. So I'm a big fan of Star Wars, so I took this example. So there's a public API, it's implemented, and this is a nice way to sort of explore GraphQL as a query language, and also play with the API. So I really like it. It's open source, and if you actually go to Apollo Studio, one of the features that they give is to load the GraphQL endpoint and play with it. I like this because I don't have to set up a lot of tools. Of course, when you're building GraphQL, you need all those tools like graphical to explore. But when you're just exploring as a consumer, right, and you're very new, I think this is something that I found useful and I thought I'll share. So one of the things that you will see with the GraphQL is called schema. So we'll talk a bit about what is schema. But if you see schema, there's a description language where any GraphQL API has this SDL built into it. That means, the developer of the GraphQL API will create this schema, and the schema is obviously in the graph format. We'll take a deep dive into schema and see how these schemas are written. But for time being, assume that there's a whole schema that comes up with the GraphQL. So that's first thing to understand. The next thing to understand here is, of course, the schema has its own language. We'll look into the language capabilities here, but you can actually explore this, right? So how do you explore it? So basically here there's an explorer. I like this tool again from Apollo because it's pretty straightforward to explore. So like I can look at all the root types, and the root types, I know all the functions that this API is capable of, and then all the objects underneath it. So for example, if I want all the films, all the Star Wars films, I can go here and select films. I can even paginate this, pick a couple of fields. I can go back. Let me add some edges to, like nodes. um, don't worry if you don't understand what is node. We'll take a look at it in a short while. Film is an object here, so I'm going to add few fields like director, maybe producers, and maybe edges also. We could add a couple of fields, but let's take it out for the time being. So here's a simple GraphQL that we got constructed in the client, and we were able to construct this because this tool allowed us to quickly select those attributes, and then I can execute the query, and you will see that the query actually returned response. Now one thing to notice is, as you can see, the structure of the output response pretty much mirrors what you give in the in the query, right? So I said, I want all the films. So you can see all the films here. I want these two fields from the characters. As you can see, the birth year is what I wanted, and then I wanted directors, right? um, uh, Directors and the producers. So as you can see, it returned the results as I needed, right? um, it's also paginated. It's using cursor based pagination. So this is a simple example of GraphQL, um, how to execute GraphQL and how easy it is from a consumer perspective. Now let's go back to our slides to see how this thing works. So I showed you executed a simple GraphQL query, it returned the results. So what's happening? Like, what is the magic sauce behind it? How is it all working, right? So to understand that, let's take a look at this diagram, right? So what we have is, we usually, client is the one that's constructing this GraphQL query, right? And then we have a GraphQL service that's usually, hosted by a developer, or it is a managed service. Like you can pick any of the managed vendors like Apollo, Hasura, or it can be domain specific services like for e-commerce, you have HighGraph, right? Or it could be any enterprise application that's giving you the service. So the service, right, hosts a GraphQL server, or or you can say a GraphQL runtime, and the server has that runtime where it has schema and the resolver, right? So you submit the query, based on the schema and the resolver, it goes and fetch data from wherever it is. So one thing to understand is GraphQL server. Usually, the concept of GraphQL is not tied to a database specifically. It could be a database, it could be a third-party service. It's an abstract concept, right? So the idea is to actually, it goes and fetches the data from wherever it has to supposed to, and then it resolves, and then it finally returns back the response. Okay, so let's go a bit into this runtime, what this runtime of the GraphQL server has. So the runtime is usually comprised of two things. Okay, schema that we saw, I was showing you from the Apollo example, right? The GraphQL has a schema loaded, and the schema is usually written in SDL, that is schema description language, typically written in schema description language. And it has a root node, and from there you define all other entities as a graph. So that's one component of it, right? So the other component that I want to talk about is resolver. Okay, so this is very fundamental to understand, is resolver. You'll hear a lot when you talk about GraphQL, you'll hear this word resolver. So what is resolver, right? To understand this, consider this query, right? If user is a simple query, we are asking for a specific user information. We want names and the followers of the user, and we want the first 5 followers. So what happens, what is a resolver is, every field that you see in this query, right, has a function. Okay, so a resolver is a method or a function for every field that's there on the schema. So when you ask for the query, when you submit the query, what you do is, what resolver does is it executes those functions. Okay, and then it resolves. So as the name says, resolver, that means it independently tries to do all these queries, and then finally sort of resolves it and collects back and sends the response. Like there is a sort of aggregation that's happening, um, or you can say serialization that happening, once all the results are returned. So that's it. Schema, remember, schema, GraphQL has schema. A resolver is typically a function written by a developer, that resolves to a specific type or a field within the schema, right? Sometimes the function will be on an object instead of just the scalar. So we'll talk about what is scalar and object later on, but remember that resolver is just a function. Okay, all right. So the next thing that I want to talk about is, okay, so let's go a bit deeper, right? So as I said, what is graph in GraphQL here, right? So GraphQL allows you to represent your business domain to a graph. Like for example, in this Star Wars API, we know that there is going to be films. Each of the film will correspond to different planets. The planets will have residents, right? So you can represent all of this information in the form of graph. A graph is generally something like node, and then it has edges like this. So you connect 2 different nodes with an edge. That's in simple words what is GraphQL. So what is a graph? Sorry. So it has nodes, it has edges, and this is what we have here. So you represent your business domain into graph, right? So let's talk about a bit of internal working of the GraphQL, right? So when I submit a query like this, like as you can see on the left, right, typically this query corresponds to a schema. So as you can see, a schema is formed. Like we have all film, then under the film is, you can consider film as root, all film as root, and then we have film, and the film has different attributes here. It can be connected to a second attribute called planet, and the planet can be connected to, again, different object, and then the tree goes on. So important thing to understand is a graph can be formed into a tree, and that's the primary concept here. Is like, if you know from graph theory, there's a difference between a graph and a tree. So a graph can be a tree, right? So a tree means something that can be traced back all the way to its node, right? So that's what happens here, is like we'll have a tree, and we'll use this property of the tree to perform the execution steps. So there are some execution steps that actually happen. So for example, when you submit a GraphQL query, right, the first thing that happens is there's a schema parsing. So from the query, as I've shown you, you can construct this schema. So you need the schema parsing. So basically, you will need something like all the fields and the attributes that are here, And then, as I said, every attribute here has a resolver function. So a schema parsing kind of is a way where it creates a dictionary of or a map or a JavaScript map of with the key as like that specific field name or the schema name in the form of a graph, and every schema has attributes, and that attributes correspondingly map to the resolver function. Okay, so that's the first thing, schema parsing. The next thing that happens is query parsing. So what happens in query parsing is when you actually submit your GraphQL schema, right? Um, you can represent this whole GraphQL query as AST. So when I say AST, again, in my previous slide, AST is basically abstract syntax tree, and this is how the compilers work for any language. So it's no different for GraphQL. It's basically your query that you have gets converted into this AST format, and that actually helps in validating. So that's the next step, right? You have schema parsing that happens before execution so that it can know for which field, which functions to call. Then it looks into validation, by doing the query parsing and constructing that AST. And finally, the query execution happens. So in the query execution, what happens is those resolver functions are called one by one, as I said, and they are resolved, and the results are actually sent to the server. Okay. So this is like a brief overview of how I've oversimplified this. If you look into the spec, it will clearly talk about the algorithms that are being used and whatnot. But at high level, just understand this. It's basically, you represent your business domain as a graph, and then you have your schema, and then whenever the query is submitted, the schema is passed, it's validated, and then within the schema, every attribute there has a resolver function, and those resolve functions are executed, and the query sends the results. Okay. All right. So once we know that, right, this is how a GraphQL is implemented by developers. So GraphQL itself, understand that GraphQL itself is a specification. So if you search for GraphQL spec, it will be a document which specifies the specifications of the query language, of the SDL, the schema description language, right? So developers implement with the programming language of their choice. So for example, if you actually go to graphql.org, you can see, it has, when you go to the code section, it has language support for various languages, because GraphQL is a spec, so it's up to the implementer to implement it. They define the spec and tell you how it works, and you actually code it in the language of your choice. Now, one thing I want to point out is don't go and host your own server. In my experience, I've always benefited from managed services. There are so many vendors out there who have gone through this journey, and they know what is the best practices, what works for GraphQL, what doesn't, how to scale, how to add monitoring and all those capability, right? So it's important that you take advantage of the innovations that they are doing. So it's important that you find managed services specific to your domain, and if there is a service, and prefer that than building your own. Okay. I also want to point out that there are a lot of open source tools and software that are available. Like, for example, if you go to this graphql.org.code, they'll show you different open source tools and libraries and everything that's available. So that's something as you can go and always rely on. It's an open source. There are open source tools and languages and libraries, and there's a whole community backing it up. Okay, so now let's get into the syntax and the specification. So first we'll go into the language, right? So this is a simple GraphQL query. You submit, you get the response, right? So let's go behind writing this, right? So when we write a GraphQL query, the first thing you'll specify is the operation. And the GraphQL has 3 different operations, like query, mutation, and subscription. Okay. So you can indicate that, like here, the operation type followed by operation name, which is up to you. It can be any operation name that you want. And the next thing we have is what we call it as selection set. So the selection set is basically an object. Okay, and every again, the selection set can have different fields, like as you can see here, all films, we are asking for films and the field. So that's simple it is to write. You specify the operation type. You might need mutation. Mutation means when you are trying to update database. Subscription is when you are trying to listen for events. Query is when you are querying, right? So you can specify the operation type, the operation name, and then the fields that you need. Now, one thing to understand is, as I said, like everything here, right, is a function, right? So that means you can pass the arguments. So this is an example of how you can pass the variables in, right? So your GraphQL query can have a variable like this, int, and then you can your resolver function can also allow arguments. So, for example, in this case, I can pass first, and that's what I will pass down as a query variables. So those variables are passed down, and then you can have you can provide arguments to your functions as you build along. Okay. The next thing that I want to talk about is aliases. So when you actually do some GraphQL, you can alias. So for example, when I'm doing, let's say I'm executing this query, right? For, let's say, for the producer, right? I want to add aliasing. So I can say PRD. So that's it. So when I execute this, instead of like producers, it said PRD. So I can alias. So I can change the things. Also, I can ask for the producers too. Like I can duplicate the data if I want to. So as you can see, it's giving me the alias one and also the new one. So I think this is pretty cool in my opinion, because it gives flexibility for the client to change things, without having to write some extra code. The next thing that I want to talk about is fragments. So fragments are for reuse. So for example, in this query, as you can see, all vehicles and all films, we have some common fields like title, release date, opening crawl, ID, producers, director. So I can create a fragment on that and then just put the fragment with the 3 dot. So that allows for reuse, right? Instead of me having to specify all the fields again and again, I can create a fragment within my query and then pass it on. The next thing I want to talk about is directives. Directives are also very important. So it changes how a part is validated or executed by the server. So for example, if here I have add skip. So in this example, I'm saying to the server that hide the producers column, right? So I can pass a variable called hide producer. And since I have a directive here, I can change the behavior of this response. Similarly, there's something called include, and you can construct your own the GraphQL specification shows you how to create directives, so developers can add in their own directives. Next I want to talk about is the type system. So there are different types here. So again, there are different types here. It starts from the root, as you can see, and then it goes into the various. So first it starts with schema, then we have different scalar types, like as you can see, a couple of examples here, like list type, non-null types. And then you have custom scalar. That means you can build your own scalar, right? So if a scalar is not provided, like for example date, you can build your own. You have enums like any other language. You have objects. So with a type, you add the type key and then you can create an object. So instead of scalars, you can group them and create an object just like any other programming language, right? And then we have interfaces. So that's also a nice way. So if you have a common interface and if others are actually implementing them, you can create interfaces, and then your query can actually specify them. So that's interfaces, and then you can also do unions. I'll share the slides with you so you'll have them. And then we have input object, right? So instead of your variables can also be an object instead of like scalars. So you can construct an input like this, and then here. Similarly, you can extend it. And the last thing that I want to talk about is introspection. So introspection kind of allows GraphQL allows you to ask schema about the GraphQL. Like for example, I can say, give me all the data types that are supported, right? I can also say, I can put a specific object type and get all the information, like its field, its different types. So this is what allows you to autocomplete. You saw when I was doing the autocomplete of my queries. So yeah, this is what it allows you to do that. Some considerations to take care, generally GraphQL, you have to consider batching and caching. Don't make it too chatty. Don't create n+1 graph problems. So you can Google about it. There are data loaders and libraries available. Also consider, if your solution is going to be scalable, consider federated GraphQL architectures that Apollo sort of highlights. And then make sure to reduce latency. One of the ideas is, if GraphQL works with a graph database, usually the latency is reduced. So these are some of the things. Now I'll let you for time for Q&A here.
Perfect. So we have a minute or two for Q&A. So we'll wait and see if we get anything from chat on that. So overall, that's a really amazing overview of all the different syntax. I'm gonna ask like a fun question for it though. What's your favorite piece of syntax on all the things that you just kind of presented on? What's your favorite grammar or whatever?
Yeah, I think something that I found it really hard to wrap around initially was non-null values. I like how you can put exclamation there. I haven't seen in any language, or maybe I'm not familiar with any language other than GraphQL that does that little exclamation, and then
The simple little shorthand for it makes
yeah,
it very easy to kind of just add it in when you need to.
absolutely.
All right. Looks like we're not getting any questions right now. So let's give a round of applause, virtual applause, for Mohit.
Thank you.
And thank you so much for sharing all this knowledge with us today.
Thank you.